I like to start AC with this experiment where you connect the 12 volt bulb to 6 volts and use an analog voltmeter. And you connect that there. And you can see, there's 6 volts there, and you can probably read that on that display. And so the task is to compare the brightness of each bulb, and so you stick it into 6 volts AC. And the pupils have to then go, okay, well, yeah, I think the bulbs are basically the same brightness, and so that's question one. Then they come over to the voltmeter and they go, oh, it's measuring 0. Oh, maybe the voltmeter is faulty. We'll put it back up into 6 volts DC. Oh no, it works. And so we play a little bit of a game about that, and then we say, well, why could that be? And then we say, well, can we plot this using vernier voltage probe? So there may be after a little bit of discussion around what is AC and maybe why is it different. We connect, in this case, a vernier go direct voltage probe in exactly the same way. Vernier graphical analysis at a sample rate of about 1,000, and you don't need very long, 0.3 of a second is great. And you click done, and then you can click collect. And so we're getting a pretty steady voltage of about 6.6 volts. And so I could theoretically reduce that down a little bit so it is measuring 6 volts by just changing the dial, and then I can do it again, and we can see pretty clearly that it's measuring a constant flat line. And then we go, okay, well, let's compare and contrast. If we click that into 6 volts AC, and the bulb, looks basically the same brightness, and we hit collect this time, and we can see that it's a sine wave. And so we can then compare and contrast. So we can just zoom in on one little bit, and if I was to go to potential on the left and go to data set 2, which is measuring the 6 volts, and again I'll just look at a small section, put a little magnifying glass, and then if I was to integrate the area under there, click the little button, view integral, look at that, those areas are perfect, 0.061 volt seconds. And so basically what we're saying is that that DC voltage of 6 volts is equatable to the average of the AC, and so those little bits filled in are equivalent to that big blue bit. And so we're starting to build these ideas of what is RMS. Probably before I get to that point, I would say what is the frequency, and so I'd get them to work out that time period 0.097 and 0.117, and take that away and you get 0.02, and 1 divided by 0.02 is 50, and so we're getting 50 hertz out of there, and we'll connect that then to the 50 hertz supply. And then that's about when you start going over the notes around that.